So hey guys, welcome to the channel. In this video we are going to discuss the remaining part of surface chemistry, that is colloids. So what are colloids? Colloids are the mixture in which microscopically dispersed small insoluble particles of one substance that are suspended into some other substance. Is like this is this substance and some other substance. Then these small particles, this, like this. These are suspended into the solvent. Okay, so these suspended particles are known as colloidal particles. So now we come to true solution. What is true solution? True solution is which have dispersed phase particle size less than 1 nanometer, like 10 raised power minus 9 meter less than. So example is salt water. Like you cannot see salt in water like with the naked eyes, as you need obviously microscope to see those particles. Okay. Colloidal solution. The solution which have dispersed phase particle has size between the range of 1 nanometer to 1000 nanometer, that is 10 raised power minus 9 meter to 10 raised power minus 6 meter, like a fat droplet in a milk. Okay. Now let us talk about suspension. Suspension is the solution in which dispersed phase particle size is greater than 1000 nanometer, that is 10 raised power minus 6 meter. Like example is soil particle in the water. Like you can see the soil particles with the naked eyes, as like you have done in your like childhood also, like you have dissolved soil in water, you can relate. Okay. Then types of colloidal solution. So basically we have three types of colloidal solution, like we classify on three bases. Okay. Like the first basis is like classification based on the nature of interaction between dispersed phase and dispersion medium, and this dp and dm is nothing, this dispersed phase and dispersion medium short form. Okay, which I have written to like not to write too much. Okay. So classification based on physical state of dispersed phase and dispersion medium, this is the second classification, which we are going to discuss further. Like, and the third is the classification based on type of particle of dispersed phase. Okay. So let us now discuss the first one. Here's the first one. So classification based on the interaction between uh, dispersed phase and dispersion medium. So first one is like lyophilic. These are like lyophilic. Philic is loving. Okay. uh, Solvent loving. These have a strong interaction between dispersed phase and dispersion medium. Okay. So like example is 4NS3 plus 5O2 in presence of platinum. uh, then it's give 4O 4NO and plus 6S2O. Okay. And lyophilic, these have a small interaction between like dispersed phase and dispersion medium, and these cannot be prepared by direct mixing. These cannot be prepared by direct mixing. Direct mixing. Okay. Well, rather these can be prepared by direct mixing. Direct mixing with small amount of electrolyte. Okay, that's it for this. And let us now talk about classification based on physical state of dispersion phase and dispersion medium. Like solid is the dispersed phase in the like solid. So we get solid sol, like some of the colored gases like gemstone, which you have viewed already, like in your like locket. Okay. Then the solid phase and the dispersion medium is liquid. Then we get sol, like uh, one second, paints. Sorry, this is paint and like fluids. Okay. And solid is the dispersed phase, and the dispersion medium is gas. Then we get aerosol, like foam, dust, smoke. Okay. and liquid is the dispersed phase, and if the solid is the dispersion medium, then we get gel, like butter, cream, whipped cream, like which you have eaten on the cakes as well. Like liquid is the dispersed phase, and liquid is the dispersion medium, then you get emulsion like milk. Okay, liquid and the gas, then we get aerosol like fog, cloud. Okay, gas in the solid foam, rubber, and gas liquid form. Gas is the dispersed phase, then in the liquid is the dispersion medium, then we get foam. Okay, that is froth. Then we discuss about classification based on particle of dispersed phase. Like first we are going to talk about multimolecular. These consist of aggregates of atom of small molecule diameter less than 1 nanometer. Like the small particle aggregate together to form a multimolecular. Like they have different sizes of molecules which have size less than 1 nanometer. Okay, and the example is gold sol, and the macromolecular is it. In this dispersed phase, particles are themselves large molecules of colloidal dimension of 10 raised power minus 9 to 10 raised power minus 6 meter. Okay, so the example is glucose, starch. The starch you can like extract from the rice. Okay, so those are the example of macromolecules. Okay, now let us talk about micelles, associated colloids. Okay, when in a solution solute particle get associated a particular concentration at a temperature form a colloidal particle, then these are called as associated colloid. Like we need a particular amount of concentration at a particular amount of temperature, and this temperature is known as Kraft temperature. Okay, and these associated particles are called as micelles. And what is CMC? Like critical micelle concentration is the lowest concentration at which micelles formation appear. Okay, so let us now talk about like the methods, the preparation of the. So let us now talk about the preparation of colloidal solutions. Okay, so chemical method. The colloidal solution can be prepared by the chemical reaction and leading to the formation of molecules by double decomposition, oxidation, reduction, hydrolysis. These molecules aggregates together to lead the formation of salt. Okay, like oxidation here, like sulfur is oxidized into the like here, and reduction the here AU is getting reduced to like AU. Okay, the second method is like bridge arc method. In this method colloidal solution, colloids of metal like gold, silver, etc. are prepared, like platinum and copper also. Here the two rods of metals are taken as an electrode and placed into the cold water containing KOH solution. Arc is produced between the electrode when electron in which like arc is produced between the electrodes which form colloidal solution. Like here is a like tank like this. Okay, and here is the solution filled KOH and water, and like this. Like here are the electrodes, and here this arc form like in the form of what. Okay, so we can extract here from here. Okay, and the third method is like peptidization. In this method precipitate are converted into colloidal solution by mixing them in with the suitable solvent with a small amount of electrolyte. Okay, like ALOH whole thrice is mixed with AlCl3, then it's give like colloidal solution. Okay, and the third one is like let us now talk about purification of colloids. Okay, like, so the first method is like electrodialysis. In this method, uh, it is used to remove the impurities of electrolyte from the colloidal solution. Pure solution is taken in the paper parchment bag and placed into water tank. Between the two electrodes, impurities get attracted towards electrode, and the solution is get purified. Like, here is a tank. Okay, here is a like paper parchment bag. Okay, like this. It is hang over here. Here the colloidal solution is filled. Here is the water. Okay, and here is one electrode which is connected to the battery, and here is another electrode which is connected to the battery. Okay, so when the current passes through the like this, wait a second, let me draw the circuit. Like, this is the circuit plus minus. Okay, so when they so these the impurities came out of this paper parchment bag in the water, and the impurities get attracted by these electrodes. Okay, and like this work. And the second method is like ultrafiltration. In this process, a special type of filter paper is used which allow the passage of crystalline particles but not the colloidal particles. Okay, so basically this works on the principle of like applying pressure, and basically you do not have to understand that process. You just need to understand this, as like we have less time. Okay, the property, let us now talk about properties of colloidal solution. So the first property is Brownian motion. When a colloidal solution is observed through ultra microscope, then a colloidal particle are seen in the zigzag motion continuously, which is called as Brownian motion. The like this is the particle, and you have seen this particle in the solution, and then it will be moving like this, like this, like this, like this. It will not stay at one place. Okay, as you have seen in this figure. Okay, so let us now talk about the last one, the Tyndall effect. When a strong beam of light is passed through a colloidal solution and viewed perpendicularly, the path of incident light is illuminated by the bluish color because the colloidal particle scatters the blue color. This phenomena is known as Tyndall effect. Like, this is the beaker. Like, you have passed like a strong beam of light from here, and this just scatters from like this, and when you view this from here, when you like eyepiece, then you see a bluish light illuminating its path. Okay, then the third is electrophoresis. When a colloidal solution is placed in an electric field, then the movement of colloidal particle is towards the positive and the negative electrode, that is cathode and anode, is known as electrophoresis. Like, as you have seen, like, this is the beaker. If there are electrodes, okay, like this, and here is the colloidal solution, then these particles start moving like to their respect oppositely charged cathodes or anode, like electrode. Okay, they start moving like this. Let us now talk about coagulation. The existence of lyophobic colloids is due to the charge on the colloidal particle. Because of the mutual repulsion, they disperse in the solvent. If their charge is neutralized by some mean, then they form the PPT. The phenomena is known as coagulation. Like PPT is precipitate. Okay, the coagulation may be carried out by the following method: by adding suitable electrolyte in the solution, and the solution is like oppositely by mixing two oppositely charged salts. Like, this is the beaker, this is the solution, and the colloidal particles are like positively charged. Okay, and if we add negatively charged oppositely charged soul, like negatively charged soul, negative soul, then it will be precipitated here. Okay, like this. Okay, and some souls are get coagulated on heating, and some solution And fourth one is some sols are coagulated by agitating. Okay, and let us now talk about Hardy and Schulze rule. Wait a second. Hardy and Schulze. When an electrolyte is added to the solution, then the ion which is oppositely charged, then the charge of the colloidal particle get neutralized them and the solution get coagulated. Higher the valency of the coagulating ion, higher will be the coagulating power. Like I have told in like previous slide, like we add the oppositely charged soul. Okay, so for the negatively charged soul, like if the colloidal particle are negatively charged, then we add like this positively charged soul like arsenic Bm, and as the power of arsenic is like more like because it has three valence, like three higher valency of like plus 3. Okay, and B is like plus 2 and A is plus. Okay, so the positively charged soul, to neutralize positively charged soul we require the negatively charged soul. So we use FeCN6 that's contain the minus 4 valency, and PO3 minus that 3 minus valency, and SO4 like 2 minus valency, and Cl minus just a single valency. Okay, and let us now talk about the flocculation value. The minimum concentration of electrolyte required to cause coagulation is known as flocculation value, and its unit is millimole per liter. And let us now talk about productive colloids. Lyophobic salts are unstable and non-reversible. If a small amount of lyophilic colloid is added into its, then its stability increases. This process is known as the protection, and lyophilic colloids is known as protective colloids. As let me give you an example. If a small amount of gelatin is added to the gold zone, then its stability increases. Example, let me write here. A small amount of gelatin plus gold salt, then stability increases. Okay, this is increased. Okay, and let us now talk. Wait a second. Let us now talk about gold number. The number represents the protective power of lyophilic colloid, which is also known as protective colloids. Okay, so the protective power is inversely proportional to the gold number. The minimum amount of protective colloid in mg to protect the 10 ml of gold salt to protect it against like 1 ml of 10% of NaCl. Like what it means to say is like the minimum amount of protective colloids to in mg, like 1 mg, 2 mg or 3 mg to protect like 10 ml of gold salt to protect it against 1 ml of 10% of NaCl. Okay, so this is from my side. Till then, be safe, be sound, and keep rocking. Thank you.